Hello everyone. Today let us discuss about screw gauge and also we will learn how to measure very small diameters with the help of a screw gauge. Okay children, today let us discuss about screw gauge and how to measure the very small diameters or radius of any wire or a ball peen refill with the help of a screw gauge. Okay. So what we will do is, let us take the screw gauge. This is the screw gauge. So what are there in the screw gauge? Let us see what are the parts of the screw gauge. So here you can see mainly what we want is, this is the main scale. This is the main scale. This is also called as the pitch scale. Now this is the circular scale here. So this circular scale goes on rotating like this on the main scale. Now, if you rotate like this, you can see for one rotation, you can keep 0 mark here and come back again to 0. That is one rotation. And see for one rotation, how much distance it travels here. Okay. Hope you are following.
Yes, ma'am.
How much distance it travels for one rotation, you can see that is called as a pitch. Okay. So, our topic is a screw gauge. First thing is what we have to know is pitch. Pitch means distance moved. Distance moved by the screw divided by number of rotations. So what I have done here, just I have rotated for only one rotation. For one rotation, how much distance it has gone here? Only 1 mm. So for 1 mm distance, it has gone for one rotation. I have done here for only for one rotation. So pitch of this screw gauge is equal to 1 mm. Up to that it's understood now?
Yes.
Yes. Now we want least count. Least count means the minimum distance we can measure with any apparatus is called as least count. We have seen in the vernier calipers it was 0.01 centimeter. Now least count of this screw gauge, how much it is? That is given by pitch divided by number of divisions. Number of divisions on this circular scale. Okay. So now pitch means just now we got 1 mm. Number of divisions you can see here clearly 100 are there. Good. So that means 1 divided by 100, that is 0.01 mm. So least count of screw gauge is 0.01 mm. So this is the minimum knowledge which we should have. When we completely close this, 0 of this circular scale should coincide with this main line, that is 0 of this main scale. 0 of the circular scale should coincide with the 0. Now this is a new screw gauge, so it is coincided. So that means there is no error in this. This is a perfect one. So when you perfectly close this, when you move this one, this is called as ratchet. So when you do this ratchet, you will get this sound like this tick tick sound. Yes or no?
Yeah.
So that means it is closed neatly. That time this 0 should come exactly straight like this. I hope you can see.
Yeah.
Okay. Now in this case there is no error. But there are some cases where there is an error. So for example, my screw gauge and that screw gauge, whatever that is there in your hands, it doesn't have error. But here if you see this picture, okay, in this picture if you can see, 0 is not coincided here. 0 of the main scale is above, 0 of the circular scale is below. Okay, so now if you see which division is coinciding with the main scale, you can count here. This is 0, 1, 2. That means second division of the circular scale is coinciding with the main 0 of the main scale. In that case, what we have to do, we have to find the error. That is called as positive error. So in the case of positive error, what we have to do here, we have to write it as the zero error. So in this case it is positive error. So in this case it is positive error, second division as you have seen here. So take that as second division, multiply with the least count, that is equal to 2 into 0.01 mm, that is equal to 0.02 mm, or it can be 0.002 cm, centimeter. So when you are taking the reading, how you have to do? Corrected reading, this you have to be very careful. Corrected reading is equal to observed reading minus zero error. I hope you got it. Observed reading minus zero error. This is in the case of positive error. Sometimes it may be negative error. So now if you see in this picture, you can see this picture. So here what happened, 0 of the main scale is here, but 0 of the circular scale is above. Previously it was below, but now it is above. When it is above, we call it as the negative zero error. When it is zero negative error, let us see which division is coinciding now. So here it is 90, 91, 92, 93, 94th division is coinciding. Then how to find the zero error here? So how to find the zero error now? So in this case, if you see now here zero error, here it is negative error. So in this case, the coincident is 94th one. So what we have to write? Minus n minus coinciding circular scale division. I hope you got it. I am not writing full form, into least count. So this is what we have to do. That means total number of divisions are 100. Coinciding one is 94 in this case. Into least count 0.01 mm. Okay, so that will become minus 100 minus 0.94. Okay, so that will become minus 0.06, minus 0.06 mm. If you want to make it cm, minus 0.06 cm. So that will be the negative error. So in case of negative error, what we have to do? So in case of negative error, I'll write here, this page is over. In case of negative error, zero correction is equal to minus zero error, that is a negative error. In this case, corrected reading is equal to observed reading plus zero correction. If you know this much, it is more than enough. Now we can start measuring. Okay. So now to measure, first you have to make the tabular column. As usual, I am making a rough tabular column. You have to make the main one, serial number and main scale division. Then you can have circular scale division, that is coinciding circular scale division. So I made CCD. Then this is in millimeters. Then after that, coinciding circular scale division into least count. So that is also in millimeters. Let this be capital A, let this be capital B, and the reading is A plus B millimeters. Suppose if there is an error with zero correction, with error correction, you have to write here. And that will be the final. Okay. So now take 1, 2, 3, 4, 5, 6 readings. One reading I will take. So this is our screw gauge. Now open it and take any small one. I took one refill over here, ball pen refill I took. So open it and you can keep like this and make the screw ratchet tight. So once you get that sound like tick tick, now it's all we have fixed it. Now you see which is the division. So first one is 0, 1, 2. Second division is there. Can you see? Yes or no? So that means main scale is 2 and coinciding circular scale division. So this is 70, 80, this is 90. So here you can see this is 85, 85, 86, 87, 88 according to me. You also please see. Am I correct?
Yes.
Yes, no? So this is 88. So 88, don't write mm now, just write only the division number. I'm striking off this mm. Then here we can write mm. 88 into 0.01, that will become 0.88. Now final reading will be a plus b, that is 2 plus 0.88, that is 2.88 millimeters. How small, no? 0.88 millimeters. To measure it is very difficult with ordinary scale, but with screw gauge we are measuring 2.88 accurately we are getting. So because this doesn't have any error, we need not write anything here. So like that you proceed with 5 more readings and then close. After that take average of all these things, add all of them, divided by 6, and that will be the final reading. So when you are taking the readings, don't take everything in the same position. Keep on changing like this one time, okay, like this again another time. Suppose if you have like this vertically, horizontally, change the positions, and at different positions you take different readings. So like that, then you will get the best results. Okay, we'll meet in the next video with another topic. Thank you for watching this video. We will meet in the next video with some other topic. God bless you all.